Welcome to sharing 3D content with scene layers. So my name is Sean William Morrish. I'm a product engineer with the dev team in Redlands. This is Tamarat Island. He's a product engineer and a developer with the 3D team as well. We'll be talking about the OGC Community Standard I3S scene layers and how to generate, create, and share those layers, and also getting into the spec itself and how you can use it in your workflows. So how many here have worked in 3D or have work going on in 3D and have generated? So quite a lot of people, and hopefully we'll answer all of your questions and make it easier for you to do your job. So to start off with, I'll just go through the different types of features that we support in the scene layer features. So this is for both online, in enterprise, and also generating local scene layer packages. And we have a future development going on, which would be for packages, map packages, which are scene packages as well. So to start off with, we have the index 3D scene layers. We have 3D objects. So 3D objects are anything that is multi-patch in the file database or shape files. So buildings, utilities, or other systems. We have integrated mesh. So integrated mesh is anything that is generated from photogrammetric modeling using drone to map, Bentley's context capture, Pix4D, or Vricon data. And it's a contiguous mesh, colored and textured, and covers the ground completely. Then we have 3D points. So 3D points are the ability to share millions of points with attribution and also symbology. So based on the attribution of the feature, we can symbolize it by height, in this case trees, by height, by girth, and by species. And then we have point clouds. So point clouds are very large LiDAR or photogrammetrically generated point cloud data sets. And we can support anything up into billions of point clouds. So there is, if you have a large county or city set of data, either flown, generated by mobile capture or by terrestrial, we can consume that, output it, and make it usable for your constituents, so they can, all that data that was stuck in a hard drive and had to be shared locally can now be streamed over the web or over the network. And then finally, our latest set of data that we now include in the scene layer in I3S is the building scene layer. So we have had a lot of requests from users to incorporate BIM into their models, to be able to consume and output BIM models from that. So we now consume Revit natively in Pro, and we have this new building scene layer which shows mirrors exactly the model and textures of the Revit layer in Pro to online as well. And it has the ability to have all of the different structures and all of the symbology that you have in that Revit file. So how do you take all of these sets of data and then output them and then incorporate them into either a scene layer or into a map package that you want to use or your users want to use? So we start off with, this is an example of most of those data types combined. We have point clouds, 3D buildings, points in a single set, and it has over 1 million buildings from the city of New York. There is 6 billion points which were captured after Sandy. All of the buildings are geometrically correct. And also any attribution that was in those buildings is also retained and can be queried. So you have all the information that is there. And the same then for point features. We can actually symbolize them based on the species, height, and girth of that tree as well. So to actually create a set of, so how do we actually create these? So to do that, we use Pro. And there's a number of tools in Pro that allow you to actually generate that output and features. So we go to Pro, and here I have, this is the city of Portland, is a small section of the city of Portland. We have the trees for this area. We have a set of buildings, and we also have the LiDAR point cloud data. And we can generate not only in a global scene, so this is all in WebMercator, overlaying or laying on top of the ArcGIS provided base map data, but we can also create the same model in a local coordinate system. So if you want to have a standalone model that is relevant to your local state, plane, UTM, or national grid, you can publish this in that format too. I worked with the national mapping for Norway. They're so far north, they don't want to use WebMercator, so everything, they had the whole country published in the Norwegian national grid. So but what you have to do with this is, because you do not have the base map or any of the base imagery or topo, you have to provide that yourself. And as you can see, this is provided the elevation and also the imagery for this particular model. So there are 3 different ways of generating scene layer packages or scene layers. We have a set of GP tools, which they used to be all in one single tool, but we have split them out so they can be, the tools can be automated. So you have generate scene layer package for buildings, points, point clouds, building types, and also we also consume OSGB meshes to output them as SLPKs. So we don't generate meshes in Pro from imagery. That is done in Drone to Map or other photo modeling tools. So this is a simple way to do it, and then once you've generated the SLP locally, you can then publish it to online or to your enterprise, or you can consume it locally on your machine, either in Pro, Runtime, or in Earth as well. So any of you who've used Earth, it's a fast and simple free viewer for all ArcGIS or any GIS data. So to do publishing, so there's that way to do it. So if you want to publish directly, there is a share tab which allows you to publish the web scene. And within that, it asks you provide all of this metadata information, a description, some tags so people can find it. You decide who you're going to share it with in your organization. And then there's an analysis tab which will look at all of the features in the model and see whether or not they can be published directly out. And once that's been passed, you just hit the share button, and then it will run, and it'll give you a update as it's running. And then once it's finished, it will give you a link to the actual web page. So in this case, I've already published it. And this is the resultant web page, a web scene. So it includes, as you can see, it includes all of the features that were in the original model and has all of the attribution that was in that model as well. So not only can I publish from Pro, but I can also consume that data which is online and has been published either to Enterprise or to ArcGIS Online back into Pro and use it as a base data set for my work, or I can do some editing and then republish it back up. So in this case, what I'm doing is I've consumed that New York web scene, and it includes all of the data that was in there, and it even includes all of the bookmarks that were available in that web scene. So I can make some changes, change symbology, change density, add some other local features, and then I can go back here to the Share tab, and I can publish back up to the web scene again. So if you want to automate any of these, there is a set of samples which allow you to see the types of things you can do in ArcGIS Online with the JavaScript API, working with all of this content. And also from Pro, there is a set of scriptable, Python scriptable examples which allow you to automate if you have a large collection of buildings, terrain, imagery, LiDAR data. Allows you to consume, cook, and publish those data in an automated fashion. So similar to Model Builder. So that's a quick introduction to what is possible and how the sharing works. I'll pass over to Tamarat now, and he'll go through a bit more depth and detail about the actual spec and also the types of sharing that you can do with it.
Thanks, Sean. So how does the magic happen? What is it that actually drives or allows you to share and publish massive amounts of geospatial data? Well, it's through I3S, Indexed 3D Scene Layer, we call it. It's a format that allows you to stream massive amounts of geospatial data. And if there's anything I want you to remember out of this session is three things. I3S allows you to stream massive amounts of geospatial data. It works on a browser, desktop, and mobile, and it's an open format. It's a format that Esri put out to the community as an open format and is shared or is adopted by OGC, the Open Geospatial Consortium, as an open standard or format. So just sort of to recap what Sean has shown us, there are 5 layer types supported. Just last week, we released an update to the I3S specification or standard that also included building scene layer. So 3D objects, those are your buildings or objects, 3D objects that you would have in a scene, in a cityscape. Integrated mesh, this is skin of the earth type of data that you have that has both geometry and texture. Points could be symbolized with realistic symbols or representative symbols, as well as point clouds were all supported as part of the I3S original offering. Now with this update to the I3S standard or spec, we released as a final version the point cloud specification, very detailed specification of point cloud, as well as an addition to building scene layer. And this is building information model. This is how you can bring your building information model, such as you find it in Revit in a file format or others, into the GIS world. As I said, the specification is an open standard. Anybody can implement it, royalty-free. Organizations that churn out data, such as Context Capture, Verican, are all using it as a standard to transmit massive amounts of geospatial data. So, the spec is in detail provided here, and we're working continuously to update it and incorporate new features into it, and then also work through the OGC community standard adoption process to get it ratified and approved as an open standard. But what does it mean, massive amounts of geospatial content? I don't like using loaded terms, but well, for example, here we're looking at city of San Francisco. I have about 100,000 buildings representing the city, all thematically displayed or thematically attribute driven. So one of my favorite aspects about I3S is that we have this notion where content could be visualized or represented from the attribute data itself. So as you can see here in this screen, the buildings that you see here are all symbolized dynamically derived derived from the attribute data. So this is just how walkable is my city in San Francisco. Yeah, the red lines and green lines represent transit lines, and the color shows that how walkable is the city, or how many minutes it takes to walk from a particular stop to any building. Now this could be changed immediately without any I can take any of the layers that are shown here and change the layer style to show a different parameter, to use a different parameter in the layer. And this is all possible because the attribute or any tabular information associated with the layer is also captured with the I3S layer, and any browser application or desktop application can quickly override that and change the symbolization. So dynamic styling is one of the powers of I3S that allows you to do that. But it doesn't have to be only thematic data. It could also be, highly realistic texture buildings. Again, about 100,000 buildings for city of San Francisco, easily navigating on this was not possible a few years back because we're really using just the browser out of the box, no specialized software or hardware required, and being able to navigate and stream high fidelity content quality is really a breakthrough in all senses. Well, how does it happen? Well, because we build, when we are generating the data or cooking data, we build this multi-LOD data structure. We have a bounding volume hierarchy that actually allows you to traverse the data structure before getting any content. So in essence, any client application will be able to traverse the tree, find out what level of detail it needs to render at what zoom level, and only then and then will only request the content that it needs to display on the screen. So that makes it very scalable, efficient, that you can load 100,000 buildings in San Francisco, or you can go ahead and load. This is an integrated mesh layer for New York City, covering many square miles, and efficiently being streamed to the screen. So all this again is possible because of this bounding volume hierarchy-driven architecture and multi-LOD structure that we have with any I3S layer. Quickly to recap, the new addition, building scene layer, Revit or building information model is very popular format, and a lot of users wanted to bring that into the GIS world, into the ArcGIS system, and we did the same kind of principles that I was describing for 3D objects and point clouds, similarly also for building scene layers, where such type of a layer actually will bring in different needs or paradigms of navigation. For example, here you would actually want to be able to peel the layers in this layer so that you can see, as building information layer contains very detailed information. Could be as small as the bolts and nuts on a building to including structures such as chairs or tables. So having a dedicated tool such as the slice tool here in the web scene viewer as well as in ArcGIS Pro allows you to reveal content in the data. So in this case, for example, you can just choose the plane that you wanna slice it on, and just by moving the plane up and down, you'll be able to reveal content inside. Now, this is not just the graphics content that you see on the screen, but this is a feature associated. So I can actually select any building, any object in here, and be able to bring up any tabular information or attribute information associated with it. And not only I can just display it, but I can also use it to drive the symbolization and representation that you see on the screen, as I've shown previously in the San Francisco use case. Moving on, the OGC standard, as I said, I3S is adapted as an OGC standard. We're working closely with OGC to continually update this content. Just last week, we submitted an update for the current version of i3s 1.6 to OGC to include point cloud, and we'll continually do so to update, when we add new layers and contents. The i3s spec that lives in the GitHub and managed by Esri is a living, breathing document, and this one will take a static snapshot of that and show it. And just to finish up, the last thing that I would like to show is that, as I said, i3s works in mobile, browser, and desktop. So how about the same content that I was showing being shown here on a browser? So here I have a Chrome browser here. I'll just go ahead and load it and see some of the content that I just showed you on the desktop also working here on the browser. So this is very powerful, being able to share the same content to colleagues and people that are interested in this content just as a URL. You can send that link as a URL, as a website URL, and be able to bring the same information that you see on the desktop and mobile and the desktop experience. Also, now how are we able to do this? Well, we are able to do this because in i3s we capture optimization that target different platforms. For example, when you're running your content on an iOS device, there are texture optimizations, as you see in this case, that we generate that would be appropriate for iOS device. etc2 is a texture optimization that would be able to be taken advantage of on iOS, so that gets generated when you generate the content. Likewise on desktop, when you are running this content on a desktop, there is compressed textures that allow it to stream or be very conservative with memory usage and be able to load massive amounts of data. This experience again was not very possible a few years back to just do it on simple Wi-Fi connection or LTE connection and running on a browser on a phone. Lastly, just to show the same experience, the same bookmarks that you have, the same streaming experience that you see on the desktop are also, will also carry over to the desktop. Some of the tools, for example, the slicing tool that I showed, might be a little bit challenging to do so in a mobile environment or in a browser environment. So we allow or we expose those tools as they make sense onto a small screen device. But it's not only on a browser that it can do, but a native application. For example, if I pull up the Esri SDK sample, native application written against using the Esri runtime SDK samples can also consume the same content. So I'm just pulling 3D objects layer that have both mixed elevation imagery as well as 3D objects content streaming to this SDK sample that we have. And the experience is actually very immersive. Even on a mobile device, you can navigate. See a stop sign, you're going the wrong direction, so maybe better to rotate. But the idea is that author publish once and be able to consume everywhere, whether it's a desktop application, a mobile device, or a browser. All right, Sean, you have a point to share? One more? Yeah. So we have only about 5 minutes left in this session. If you have questions, you are more than welcome to ask at this point.
Yep. So the question is, does building scene layers support textures and materials? So building scene layers, currently we do not. We support the, because it is derived from Revit data, it is what is in the Revit model that is supported. So,
but to add to that point, for Revit models that have texture and material, right now in the first offering we don't have support for that. But in our second, that's already in our plan to be able to support Revit material, Revit format that has textures or material. So right now, majority of the building information model data that you see does not come with texture or object, but it's something that is already in our plans to look at that. Any more questions? Comments?
Yeah.
Sure.
Have you got any plans to add a second
For the slicing, actually the slicing, you can use the clipping plane. So you can actually define which plane you want it. But what you're asking is, can I set one plane here and then add an addition at the same time? Not something that we have considered. Maybe, yeah, we should. Now, the experience, the challenge is that we want to make a homogeneous experience throughout the experience. The same experience is available in ArcGIS Pro, in the web scene viewer. So the challenge usually is like, how to, and then people wanted also the same thing on the mobile system as well. But something that we could consider, like locking one plane and then be able to also interactively add yet another one. But one thing you can do here is you can exclude a particular layer from being sliced, so that if you don't want it to be participating in the slice, you can actually exclude it. But more than one clipping planes we don't have right now. It's just a single plane that you can choose. Oh, sorry. I thought I was showing the.
All right.